Welcome back, quantitative students. Today we're going to do two subtopics here in quantitative analysis. We're going to focus on simple interest, which is using the formula I equals PRT, along with the concepts of present and future value, word problems associated with that, especially using specific quantities for variables. Then we're going to focus on arithmetic sequences and how it applies to continuous compounding and regular compounding. That's what our mission is today. And then at the end of that, we're going to focus on our exam number 3, which is coming up next week. And I'll give you those details as well. Today is June the 23rd, 2022. First, let's talk about a very basic concept that we all are familiar with. Quantitative analysis students, I know that you are studying business in one form or another. I have people that are studying finance, people that are studying marketing, people that are studying entrepreneur. You all have different majors, but one thing I know that you do have in common is you understand the ROI, and that is the gains on investment over the cost of the investment. It's the concept of how much am I going to get back based on what I'm putting into any specific financial commodity or something like that. We have a return on investment. The return on investment is a fraction. It's a fraction that represents the part of the money that you're putting into this investment that you have gotten back. Have you gotten back 10% yet? Have you gotten back 40% yet? Whatever you get back is the top number. The bottom number is the total of what you put in. That's why it represents a percentage of how much you've already put in. Like how much of what you put in have you gotten back so far? Hopefully, if you're fortunate, your return on investment will become greater than one and really explode. And that's the whole idea of trying to make profits and be successful in business. So anyway, return on investment is the gains over the investment. Okay. The other important topic we're going to really throw around a lot here is the simple interest formula, which is capital I equals capital P times R times T. These variables represent interest, principal, annual interest rate, and time, respectively. As you see there, some little details. Make sure that you are in the correct label. Your interest and principal must be dollars, and your interest rate must be in a decimal form. Likewise, your time must be in years. A note about your interest rate. It is crucial that you remember the little trick about how to change from a percent to a decimal, even in odd cases where the decimal is out of place, misleading you to think to move it the wrong way. We have to get a solid grasp on it. It should be elementary to us, especially if we're business people. Remember, I always go back to a benchmark idea of I know what 50% is. It's 1/2 or 0.5. And if I ever forget which way to go with the decimal point, when you're going from percent to decimal or decimal to percent, do you go left, do you go right? If you get confused, use the model of what 50% is. It's 0.5. So you can think about the 0, 50 period and the period coming 2 places left and all that. So let's make sure we have a good grasp on the percents to decimals skill set, okay? And then also we have the time, make sure it's in years. So there are some little factoids we assume that you know. There are 52 weeks in a year. There are 12 months in a year. There are 4 seasons or quarters in a year. There are 365 days in a year. So if we invest for 108 days, then, the time is 108 over 365. You have to know to make it a fraction and such. If you invested it for 9 months, then it's 9 over 11, 9 over 12 years. You have to use fractions in that way, sometimes to express quantities of time because the label is in years. Those are the two things that might throw you off a little bit if you don't remember those lessons from back in middle school. And they are easy to forget because they're a little confusing. So if you forgot them, just kind of refresh yourself. You can always just YouTube or Google something about how to do percents if you need to just remember how to do it. So once again, don't forget R and T have to agree. In other words, it has to be, if it's a rate, it's an annual rate, then we need to make sure that our time is in years. If it was something like a daily rate, then we need our time in days and such. But the good news is here in quantitative analysis 1, we don't really kind of mess around with that. It is almost always years. I haven't seen any of the word problems other than years. So it sticks to years and they agree. But if the point is make sure that your R is based on an annual rate, okay? So let's get our feet wet and try a couple of examples. Here comes example 1, where we're going to just use the I equals PRT formula in a basic 7th grade style math application word problem. If 8,000 is invested for 2 years, the annual interest rate is 9%. how much interest is going to be received at the end of that period of 2 years. I equals PRT. You just plug the numbers right in the way they look, and it comes out just like that. It's a piece of cake. I'm trying to highlight. I'm looking for my highlighter. Hold on, friends. Where is it? It's funny, I can't see. Oh, there it is. Okay. This is what I was going for. Okay. I like red though. Blue is a little better. Okay, so I'm right here looking at this math, right? And you could see that all we have to do is just kind of insert all of those different things in there. Make mention when you're studying that 8,000 is the principal that represents capital P. 2 is the time, that's T, and it's in terms of years. 9% change into a decimal is 0.09, that's the R. And of course, at the end of the 2-year period is kind of code for just use the formula. Okay, so that's the answer for part A. Let's focus on B now. It's the same question, okay? A little variation. If 4,000 is borrowed for 39 weeks at an annual interest rate of 15%, then how much interest is due at the end of the 39 weeks? Notice it's at the end of the 39 weeks, just like part A was at the end of the 2 years. That's how you don't have to play around with dealing with a piece of the answer in any way. You could just use I equals PRT. In other words, I equals PRT only works for the entire length of time of the loan or of the investment. All right. Also, we have the dreaded 39 weeks. Now, do you remember your math vocabulary? How many weeks are in a year? We just said it's 52. That's why we see this interesting fraction in our solution, 39 over 52. That comes from our time being 39 weeks. And 39 weeks, of course, over 52 represents exactly 3/4 of the year. Likewise, we have 15%, that should be 0.15, and you put it all together and you get 450 bucks is your answer. Now, something else I want to mention, these two questions are put together, A and B, one after the other, so that you could see how they are the same question and remember things that are kind of synonyms, if you will. Like, for example, we have right here, it's being invested. Then here we have it's being borrowed. Okay, please pay close attention to that, friends. That's a very easy thing that'll make your homework easy. You know, if you're calling it an investment, or if you're calling it a loan, you know, or if you're investing this money, or if you're borrowing this money, it's still the idea of money going from one hand to another with a contract of a percent and such, making interest and the rest of the story. So let's think of those two words kind of like they mean the same thing, like they're synonymous a little bit in our studies here with simple interest word problems. All right, so example 1, you're just getting your feet wet. I equals PRT, plug them in. Do you know which variable is which? Remember how to convert odd times, remember how to convert your percents, and make sure that we're talking about annual each time. That's also kind of important. We got annual here and we got annual here because it's got to be out of a year. You know, that's another little thing to check for. All right, so we got our feet wet with it. We know how it works. Let's try to apply a little bit of a more heavier idea now. Let's talk about the idea of I'm putting money into this investment or a loan or whatever. I'm putting money in, and then what's going to happen is it's going to earn interest. And then in the future, when I am able to reap the benefits of it and take the money back, I'm going to have more than I put in. And the basic idea is the present value plus the interest is going to be what my future value will be. So I'll put money in, it will grow, and then I will get more back. So in this model, capital S is the future value. I don't know why they've chosen the letter S. It's an interesting letter of all letters to choose. I would have picked F. But anyway, capital S is your future value. P is your present value or your principal. And then last but not least, of course, the interest is capital I. Now remember, I equals PRT. So you're going to see very often this I right here being replaced with PRT. In other words, making it read S equals P plus PRT instead of I. They do that a lot to try to figure out weird questions, and you'll see every example of the kinds of questions that you'll need to be able to answer to succeed with this lesson. All right, so there's some fun, interesting vocabulary here too, by the way. The way you call S the future value, you call P the present value or the principal, or you could also call it the face value of the loan. So all of those words, face value, present value, and principal, are all synonyms. And you're going to see in WebAssign when you do your homework, sometimes they'll use the face value word, sometimes they'll use the present value word. You'll have to remember which one is which, and they're trying to make sure you're reading textbook. That's why I have this picture of the book here to share with you these words. Remember them when you're doing your homework, and it'll make it easy for you. Right? All right, so that's the model that we're going to follow about future value. Let's put it into practice now. Here's an example of a question or two that have to do with present and future values. In part A, and I'm going to read it. I want you to try to read it along with me. It is a little bit wordy, so let's focus together on it. Okay, it's if 2,000 is borrowed for 1/2 year at a simple interest rate of 12% per year, what amount must be repaid at the end of the half year? So in this case, what are we doing? It looks kind of like our last question. Let's take a look what the solution is. They're saying, okay, well, the interest for the half year is going to be specifically this. Now notice, these are the numbers they gave you straight out. They told you, okay, it's $2,000, it's a 12%, and it's for half the year. So then you think about P is 2,000, rate is 0.12, 0.5 is going to be the time because it's a half a year period. So now, if you want to think about the future, is going to be the actual amount, which is 2,000, plus the money that you've earned, the interest, which is 120. In other words, following the basic formula P plus I, which is our future value. Our future value S, the thing we're looking forward to getting in the future, we put in 2,000, we're going to get back 2,120. Okay, great. So we have the first most basic example of applying I equals PRT along with S equals P plus I. Our next question. In B, it says an investor wants to have $20,000 in 9 months. Okay, now think about that for a minute. That means the future value is 20,000, right? Not your present value P. We're talking about S is going to be 20,000. Okay, we're getting on it, right? We're on top of it. 9 months, I can interpret that as how many months in a year? 12, right? So shouldn't the T equal 9/12? Yes, of course. What if the best available simple interest rate is 6.05? That one's a challenging one, right? Because it's got a 0.05. You might be tempted to go the wrong way, but it is 0.0605. Let's do that little drawing that you remember doing in middle school. Remember your teacher going da 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 da. Right, you got to go 2 spots left with the percent. All right, so go 2 spots left with the percent. You get 0.0605. And basically what I'm looking for then is P. How much has to be invested? I'm looking for P. So look at how I can set up the formulas now. For B, they tell us, and I'm going to highlight as I'm talking different ideas here. For B, they're telling us, we know that this is an important formula. And you know, by the way, that the I, I'll do that in purple, is the same as PRT. You see that idea? Remember I told you I equals PRT? They'll replace I with that little PRT expression, right? So we can change it now to be the idea of S equals P plus PRT. So let's take it like this then. Think of it as if it was S equals P plus PRT. Not very easy to read a math book, you know, so I'm here to try to help you interpret what you're reading when you're trying to go through these examples. S equals P plus PRT is going to be our new formula. So what we're going to do is we're going to put everything into that formula. Here's the future value that the investor is expecting, 20 grand, remember that. P is the thing I don't know. I'm going to just kind of put little stars on it. I don't know what P is, all right? But I do know what the rate is. Remember we talked about how the rate is that interesting case of a percent that has a weird decimal equivalent, okay? And don't forget our 9-month experience is out of a year, 12 months. So we have here in its entirety a basic old equation from 9th grade Algebra 1. Look, it's not a hard equation, especially if you have a calculator. So get your calculator out, or you could even use Desmos to solve it. You know, you could do that too. When you do 9/12 times 0.0605, you get this. As a reminder, friends, whenever you see the variable P or X, you may assume there is a 1 in front of there like this. Right, there's a 1. I could have done that better. Let me do that one more time. Hold on. There's my 1 right in front. It's 1p. See how it's 1p, right? So isn't this like, imagine if it was 1p plus 5p. Then you would add 1 and 5 and make it 6p, right? All right, well, it's 1p plus this funny 0.0452. Look, this is what we're expecting then here. See how it's 1.0? It's these two numbers added, the 1 plus this coefficient here. Okay. And now how do you finish up? Don't you divide both sides by that strange number? And that's what you see going on right here. And then in the decimal, you use a calculator and you get this. And that's what the answer is. Now, I just want to talk about this math for a minute because this is not very challenging, hard math. It's especially if you have a model like this one here, you can come back to this slide and look at it when you're asked questions in WebDesign. Or you could come back to our video where we're discussing it together and you can remember what I said by rewinding it and stuff. Definitely look at the way this has been structured. They're leaning on the I equals PRT, and they're using the S equals P plus I. That's all it is. And it doesn't get any harder than this, friends. This is the hardest thing it is. And then now they're going to mess around with trying to find P. Next, they'll make you find R. Then they'll make you find T. Then they'll make you find S. Then they'll keep on changing it. And that's what the rest of the examples are kind of about in this. But we want to get a good grasp on it. We want to also, I want to stress to you, please make sure you carry out your decimals as very far. Notice in this example, we actually are carrying out our decimals to 1, 2, 3, 4, 5, 6 places. It goes out to 6 places. So I would go there with 6 places. It probably will make a difference on whether you get it right or not in WebDesign. Make sure you go all the way with those decimal places. Fortunately, if that's the hardest thing it is putting all the decimal places, then it can't be that hard. You got to have a good outlook with it. And it's also very practical math. It's stuff that you need to know if you're interested in business and finances and economics. All right, so I hope that helps a little bit. I'm going to clear everything out. Just remember that it's not really very clearly written here, but the formula that's really golden is S equals P plus PRT. That's a big formula we're going to keep on using. All right. All right. Let's look at a couple more examples now. All right. So example 3 is Mary Spalding. It's funny her name is Spalding. I know somebody whose name is Spalding. Mary Spalding bought WindGen electric stock for this much money, right? And we have a funny figure there. After 6 months, the value of her shares had risen by $138, and the dividends totaling $144.14 have been paid. Find the return on investment. The return on investment. Now, what does return on investment mean? Let's try to remember that for a minute. Well, I have it right here. And this was the first thing we talked about today in our lesson. This is what return on investment means. You think about how much you've made on your investment. That's your numerator. And then you divide it by the amount of the money that you put out to have the investment. So in this little story that we're given, Mary Spalding bought something for $61.25. $61.25 is going to be my denominator then of the return on investment. And then what did she make with that stock? Well, she made this and she made this. It's creative that one of them is dividends and one of them is shares, whatever the wording is, doesn't matter. What matters is that she put this much money in and then she got this much money back. So the money that she got back, we're going to add it up and that'll be our numerator. And then we'll take that and take the amount she put in, the $6,125, that's the denominator. And that will be our return on investment. Here is the explanation. We say that Mary's gains are equal to the rise in the stock's price. And when it's sold, plus the dividends, she received the stock. So as you see, we add the stock and the dividends together. And that's the numerator for the return on investment here. And then your denominator is going to be the amount that you put in right there. So when we do that, remember, return on investment is supposed to be in the form of a percentage, and you're going to get it in a decimal. So here you are now going in a backwards motion from what we were doing with the other word problems, which was changing percents into decimals. Now here's a decimal. What does this decimal 0.046 as a percent? How do you change it to a percent? Remember the model I reminded you of. 50% is the same as 0.50. It tells you where the decimal point is supposed to go, because don't forget the decimal point actually goes right here, right? There's a decimal point, so you can move it 2 spots back. So if I have it as a decimal and I want it to be in a percent, I should move 2 spots to the right to make it 50%. So let me do that here. 1, 2, and see how now I got 4.6. All right, so you got to be good with that. That's something I see a lot of students struggle with that. Often I also see students accidentally only go one spot, or maybe go too many. They go 3 spots, only 2 spots for percents. Watch out for that, okay, guys? All right, let's look at the next idea here. Find the simple interest rate she earned on this investment if she sold the stock at the end of 6 months. So find the simple interest rate she earned. It's a funny thing to ask. In fact, it's a very abstract, weird thing to ask. Let me try to shed a little bit of light on what that actually means. What is the simple interest rate she earned? Well, the thing is, the money that she earned was not based on a simple interest rate. She put her money into a vehicle, and it was 6125, and what the vehicle gave her back was 138 plus 144.14. Not because it was an interest rate, not because of any, but because it was a dividend, and because it was a stock risen or whatever, but it's not an interest rate. So what we could do is we could act as if that was interest. Like, in other words, it was not interest, but let's pretend for a minute. What if Mary Spalding, how would she have been able to earn that much money? What would the interest rate have been if it was interest? So what we do is we add together the two numbers, 138 and 144, and we think of that as the interest, and that's the new quantity that we use capital I to represent, is that amount, and say if that's the interest, and then the original amount was 6125, and the time was 6 months, which is 0.5, then what was R? That's going to be our plan. So look at how they explain it. To find the simple interest that Mary earned on this investment, we find the rate that would yield the amount of simple interest equal to the gains. And the gains are those two numbers, 138 and 144. Thus, the principal, which is 6125, and the time, which is a half year, and the interest earned, the total of the gains, are all these that we see here. And we discussed this before. The numerator here is the same as this quantity right here, which boils down to this figure, 282. Now, take a look at the concept of I equals PRT right here. This is I equals PRT. I is that figure 282. P is the original present value that was put in, or face value, or principal, right? And then we also have 6125, that's the principal. We don't know R. We also have 0.5, that's the time T in terms of years, because in code, 6 months is how many years? 6 months out of 12 months, 6/12 is 1/2. 1/2 a year, 0.5. Then little basic algebra. This is something we like to call the commutative property. You're allowed to move them around because they're all multiplied. So you can switch the R and the 0.5. So it looks like 6125 times 1.5. Do that, that's 3062.5. And then you divide both sides, and you get 0.092. Once again, you're in a position where you're looking at a decimal and you got to change it to a percent. This time the answer comes out to be 9.2%. So this topic, look at what the topic is called. Evaluating investments. You're evaluating your investment. In other words, you're saying, well, I know that I got this much back in my gains, but if it was interest instead of just dividends and random numbers I had no way of predicting, what would it have been if it was interest? And now you can take that idea of a 9.2% interest rate and match it up against the idea of the gains you got, and think about, was that a good investment? Should I have done that? I could have taken that money and put it in a money market or in something else that would have earned a different yield, right? But you know what this one did earn. It earned you 9.2%. That's a fact of what the interest would have been. That's something that will help you a lot with that, analyzing how you invest in such. All right, so I hope that makes sense. That's example 3. Here, we're going to talk about what happens when T is the variable. So the last one, which was R is the variable, you're trying to, like I said, evaluate the investment. How good or bad was the investment? Here, we're talking about what's the duration of the investment and what can I make the duration be so that it can get what I want. That's what we mean by letting T be the variable. The duration is the time. It says if 1,000 is invested at 5.8% simple interest, well, how long will it take to grow to 1,100? I want to wait until this 1,000 turns into 1,100 before I take it out. When it turns into 1,100, I'll take it out and we'll have a big party or whatever your story is, right? But how long will it take means now find out what T is in this story. So one thing we have is we know what the present value is, or the principal, or the face value. It's 1,000. That's how much you're putting in. We also know what the future value is. The future value is 1,100. Yep, you're right. It's 1,100. Then what is the rate? It's 5.8%, but I got to make that 0.058. It's supposed to be a decimal. And we're asking you what is T. So once again, we use our favorite little formula. S equals P plus PRT. There it is. And plug everything in you know. The S is the 1,100. The P is 1,000. It's written here and here. The 0.058 is the percentage change into a decimal. And of course, there's T. Don't forget in algebra, you got to do one thing at a time. First, we're going to figure out this. And then we're going to subtract 1,000 from here and here, get that 100, and carry on. And you know how to do it. It's ninth grade algebra. Finish up, you'll get an answer of 1.72 years. Okay. So that's what we needed to study, friends, about simple interest. As you see, it's only a matter of thinking of I equals PRT, and then S equals P plus I, where I can also be PRT. And then there are weird structures of kinds of questions that specifically are asking for T, then they're asking for S, then they're asking for P, and so on. So you have to know how to interpret which word problem, what procedure is to be done to each. And now you have a nice example of each one you can use when you go and do your web assigned homework. You can come and look at these examples. And they'll follow the same exact model you see there, just different numbers and maybe a little different wording and stuff, all right? The second half of today's lesson is going to be arithmetic sequences. And arithmetic sequences are your times tables. So like if you know 5, 10, 15, 20, 25, or if you recited the 9 times tables, 9, 18, 27, 36. If you know times tables and you can just say them, you're reciting an arithmetic sequence because every new number you say is the result of the last number plus the same thing again. The 8 times tables, it's the same, it's 8 plus each time again and again and again. So an arithmetic sequence is just that. It's a list of numbers that have a regular increase of the same amount. That amount is called the common difference. And of that list of numbers, we like to call those numbers terms, okay? And we think it's very important to note what the first term is. And we also want to be able to know what the third term is, or the 8th, or the 13th, or the 71st term. So we have this expression, we call it the nth term, NTH, meaning for whatever particular position I chose. Maybe it was the 14th term or the 75th term, whatever N is the nth term. So in an abstract way, there are a lot of really interesting relationships when you look at an arithmetic sequence about what the sum of a certain amount of terms in the sequence would be based on what term you're using and what the sum is and what the common difference is and other little pieces of it. And it puts you in a position where you can kind of solve for a lot of weird, unique questions of unknowns in word problems. You go really down a rabbit hole with it when you take Calc 2, and it's very interesting. You learn a lot about sequences and series in Calc 2. But here in quantitative analysis, one of the most unique applications of arithmetic sequences is the concept of investing and getting a regular return on investment that's constant, which is what you're going to see here, the application of. So in this lesson, we're going to do a little bit of old school algebra or calculus of how to do an arithmetic sequence and answer questions about arithmetic sequences. But we're also going to show how you can apply that to investments and to earning money over periods of time like you see here. So let's get started with the idea of $2,000 that you're going to invest. And you're going to earn 1% simple interest for each of 5 months. Take a look at the table over here on the left. I'm going to zoom in on it for us. And at the beginning of month 1, you put 2,000 in, and we got 1% of it, which is only 20 bucks. And you add 20 bucks to your investment of 2,000 bucks, and your new value is 2,020. Now, if we were going to just keep on doing it to only the number 2,000 and not continue to use the last one again and again, like compound interest works, and we're just doing basic, straightforward, simple, it would be 20 bucks again and again and again, as you see here. This represents an arithmetic sequence. So in this case, we would say the first term is 2,020. Then we would say the fifth term is 2,100. we would say the common difference is 20. If I wanted to, I could talk about the sum of all 5 of those terms. At a little glance, it looks like it would be probably somewhere around 10,000 something, 10,300 maybe. But in other words, something else that is important about arithmetic sequences that we have to note is the sum of n terms, the sum of the first 5 terms. The sum of the first 2 terms here is 4,060. Can you see that? So the sum of the number of terms is something else that we have to have a comfortable grasp on. The common difference, the sum of the terms, the nth term, the first term, the third term, and all those things. They're actually really very simple ideas at first. Then when we start looking at the word problems, they get a little confusing. That's why I want to keep reminding you of the simple pieces of it so that you'll be able to get the answers easy. All right, so let's take a look at this statement here. A function whose domain is a set of positive integers is called the sequence function. That's very deep. You don't have to know that. Just kind of just take that with a grain of salt. Okay, the set of function outputs of a sequence function. You see them here. What they're trying to say is that sequences and series they act as functions. When you say the first term, it's like saying f of 1. When you say the nth term, it's like saying f of n. If you say the 48th term, it's like saying f of 48. You know, and it's the same idea as looking up numbers in a table, like you can as a function. So the ordered list is called a sequence, and the outputs are, as you see, the actual terms themselves, and they're called terms. So what is the input? It's like as if you have an XY list, and on the X list, it's 1, 2, 3, 4, 5, 6, 7, but on the right, it's all the terms. The first term, if you want the 4th term, you look at the 4X, and it'll tell you. That's the idea. So we want you to connect the concept of an arithmetic sequence also to a list of XY points, like a function. So think of it like a function, okay? So here's an example associated with the terms of a sequence. This is also, you could consider this something of a brain teaser, like it's a little math game or something, but we're gonna give you some numbers and then we're gonna ask you if you can figure out what the next couple numbers are. You know? Let's see first what it's like to construct a list of numbers in a sequence. Write the first 4 terms of the sequence whose nth term is, and now we have this interesting math here. I want to talk about this. Okay, so we're looking at, and it's a little bit hard to see, but just so that it's really clear for you guys, it's really right here. This is a sub n. A sub n equals, and we have something that has n in 2 places. We have -1 to the n over 2n. So for example, if you wanted to know what the first term of this sequence is, we will call that a sub 1. Kind of like as if I said, can you find f of 1 if this is the function f of x or f of n? So if it's a sub 1, you just put a 1 in each position of n and do your math. Then you'll find out what the first term is. If you want to find the second term, a sub 2, just put a 2 everywhere you see every n and do your math and you'll get your answer. This is what it looks like when you do all that. Okay, so here's if you put 1 in all those positions, you get this math. And excuse my picture, it's a little blurry because it's a screenshot from your ebook. That's why it looks a little funny. But you could go and look in your ebook and still the concept is here. You're just plugging in the numbers where they go. As you can see, if it's a sub 2, put a 2 in each spot. If it's a sub 3, put a 3 in each spot. If it's a sub 4, put a 4 in each spot, just like you see there. All right. For the next question. Oh, it's all. Oh, okay. Oh, okay. I see what you're saying. So then here are the answers. A sub 1 is this. A sub 2 is this. Oh, wait a minute. A sub 2 is this. A sub 3 is this. A sub 4 is this. So write them in a list with commas. Okay, here you go. All right. So I hope that makes sense. That's how you would come up with the first couple of terms of an arithmetic sequence given a formula. All right, now let's do something a little deeper. There are some extra formulas here we got to talk about. First of all, we understand what the arithmetic sequence is, and we did discuss this. An arithmetic sequence, it's a progression, and there's a number d that like you keep on adding d. So in other words, whatever term you're looking at, it is the last term plus whatever that d is. Remember we talked about the times tables. It was a great example of an arithmetic sequence. So in the case of the 5 times tables, 5, 10, 15, 20, I'm adding 5 every time I say another word, 25, 30. I add 5 again, 35, right? So doing that, D is the 5, and if you think of A sub n, that's like whatever term I'm talking about right at this moment. If I was at 25, that happens to be A sub 5. Right now it's A sub n, but A sub n minus 1 was the last term, that was 20. So you don't have to know exactly what n was to know what n and n minus 1 are, as long as you realize that A sub n is whatever term you're looking at, A sub n minus 1 is the term right previous to it, and thinking of it that way, this is actually, although abstract, very obvious. This term is the last term plus the difference. That's what we're saying here, right? So that's the definition of an arithmetic sequence, and that it has a common difference. Now, let's talk about the nth term of a specific sequence. Like say I said, okay, I'm going to tell you what the first term is. And I'm going to tell you what the common difference is. But I want you to tell me what the 55th term is, right? But you could count 55 terms, right? If I said, okay, the first number is this, here's the common difference, what's the 39th term? Would you count 39? I mean, you could do that and you get it right, or you could just use this little formula right here. This formula is telling you if you want to find the nth term of a sequence, take the first term of the sequence, take n minus 1. So if they said find the 30th term, then that means 30 minus 1. Make it 29 in those parentheses, okay? Can you give me the 55th term? Okay, then this is 54 in your parentheses, right? And then times whatever the difference is, the common difference. If you put that all together, it will give you the answer quick and easy of what that 49th term was, or whatever ridiculous number they were asking you for. And when you do WebAssign, one of them asks you for the 91st term. They ask, and they use weird number examples to demonstrate, so that you can demonstrate your mastery of this concept, that you're supposed to use a formula to be finding the nth term. And when they say the nth term, that's for any n, right? So this is an important formula we're going to use today. And then we also have this formula over here. This is about the sum of the first n terms in the series. Now, remember when I showed you that first sequence, and I said, it's also important to know what the sum of the first 5 terms are, the sum of the first 30 terms, the sum of the first 3 terms. This is the formula for the sum, and notice that it's an S. It's a little funny handwriting, I know, sorry about that, but that does not say A sub n, that says S sub n right here. This is S sub n. S sub n, which is the sum of the first n terms. What is the sum of the first 14 terms? That's S sub 14, okay? That would be 14, which whatever n is, of course, over 2 times the first term plus the nth term. So if you need to find the sum of the first 27 terms, you need to know the 27th term. If you want to find the sum of whatever 68th term, you need to know the first term and the 68th term, not just the number 68, but what the 68th term was as well. So don't take it lightly. There's a very big difference between n and A sub n. In the case of the 63rd term, n is 63. A sub 63 is whatever that term was. So we have 3 important formulas here, or 3 important statements here. We have what an arithmetic sequence is. Basically, it is every term is the term just before it plus the common difference. Then we have the nth term of a sequence, which can be found using the first term and the common difference. And then, of course, we have the sum of the first n terms, which can be found using the first and last term. Now, remember how before we had that I equals PRT, and you can swap out the I for PRT? Okay, in the same way, and I'm going to change color for this, in the same way, you can swap out A sub n for all this stuff right here, if you want to. And it's parallel to this lesson that in simple interest, you have that funny substitution of one equation right into another. That actually kind of happens here. And I've seen students do it where they put that whole blue oval on the right right into the position over there, or will they do it in steps? First, let me find a sub n. Now here's a sub n. Now that number is what goes in the little blue circle on the left. Any way you want to do it is fine, but get ready, friends, for these two to intermingle in the same kind of way that those two interest formulas did. All right, so let's see. I do see a question. Let's see. Oh, okay. Oh, yes, I see everybody's here. That's good. Right? Is everybody here? Yes, everybody is here. Okay, that's good. All right. So, arithmetic sequences and common differences. We have the nth term, and we have the sum of an arithmetic sequence. So now let's put them into application, and let's answer some questions now about these. First, let's just do some basic brain teasers here. Write the next three terms of each of the following sequences. All right. So I'm looking at this one right now. Write the next three terms. It does appear that I'm adding 2 each time. I guess it should be 7, 9, 11. And that is our answer. There you go. All right. How about this one? 9, 6, 3. Yes, it happens sometimes numbers go down. So it looks like the common difference is -3 this time. Yes, you can have negative differences. So what comes next? Of course, 0, -3, -6. And here I have it, right? And then this one. This one's kind of ugly. How do I deal with something like that? Well, notice the denominators are 6s. Can I rewrite 1/2 somehow so that it looks like that? Of course I can. 1/2 is also known as 3 6s, isn't it? So if you think about 3 6s, hold on, 3 6s, right? And then 5 6s, and then 7 6s, and then guess what comes next is 9 6s. And then 11 6s, and then 13 6s. Let's give them some fraction lines. Give them some fraction lines. There you go. And by the way, this can get reduced right here. 9 and 6 both have a common factor of 3. So cancel them by 3 each. You're going to get 3 over 2. So 3 halves, 11 6s, and then 13 6s. That's what we should get there. Let me just kind of peek down there and see if that's what we got. Yeah, that's what we got down there. See? And notice, by the way, they did reduce. That came down in that 3 halves. So you can turn this into like a fun brain teaser for your class if you're trying to make math fun and all that stuff. But it's really just about getting the idea of what an arithmetic sequence is, knowing that there's a common difference, knowing if you couldn't see that you could have done that trick with the 6s, you could have gone through the hard work of subtracting these two fractions, but you would get the same thing as if you subtracted these two fractions, which is 2 6s. And then you'd know, well, I guess I add 1/3 each time. And this time, like you see, the common difference is 2 6ths or 1/3. All right. Next, we're going to talk about finding specific terms or finding specific nth terms. First, we're asking you to find the 11th term. And then we're going to ask you to find the 75th term. But we're going to give you certain specific little hints. So look at part A first, friends, okay? Okay. Find the 11th term of an arithmetic sequence with a first term of 3 and a common difference of 2. Okay, so A sub 1 is 3. Very important. C, D, or the common difference is -2. This formula comes as a result of the formula that we saw earlier, that A sub n is equal to A sub 1, the first term, plus n minus 1, which this time is 11 minus 1, times the common difference, which is -2. You do your math and you get -17. Let's just look at how that compares. I'm going to zoom out and show you. I have the model here for us also. Take a look right here, friends. This is the model to find the nth term. And in this question, we're finding the 11th term. We have a first term of 3, we have a common difference of -2. So I used this model, and I plugged in all of the important numbers this way. Notice the n is replaced with 11. It's a sub 11. Notice that a sub 1 is replaced with 3, and so on. You do your math, and you get -17. Again, the idea is you know the formula, and we give you hints, and we ask you to find certain specific things. You're looking for an 11th term. That means you need the formula nth term of a sequence for your answer. Okay. The next one, substituting on B. If the first term of an arithmetic sequence is 4, and the 9th term is 20, find the 75th term. Now that's really quite a stretch. But if the first term is 4, and the 9th term is 20, I should be able to find out what the common difference is. And if I can find the common difference, well, then I can find the 75th term. So take a look at this. If a sub 1 equals 4, and a sub n equals 20, which is the 9th term, and n equals 9 in that case, then you have this formula. And this formula gives you this. So what happens is that sentence, and I'm going to highlight it in red one more time. That sentence right there has everything but D in it. Notice that we used the nth term of an arithmetic sequence formula and put everything into the position that belongs there except for D. By the way, also, as I mentioned, we're not using the number 75 yet because we're using all the other clues to find out what D is first. Then when we know what D is, and we have the first term also in our information, then we could go find the 75th term. So the 75th term, we can't figure that out until we get D first. So we can get D if we use this formula and put everything into the position. You'll notice that everything is there except D, and now you could do old 9th grade algebra and solve for D the old-fashioned way. You get 2. And suddenly it becomes clear that the difference is 2. Now, you might have realized if the first term is 4 and the 9th term is 20, if you tried to count, you might have figured out that really if you go in twos, you'll get there. 4, 6, 8, 10, 12, 14, 16, 18, 20. If I go in twos, that's the 9th term becomes 20. You might have been able to figure that out, and that's real interesting. But you know, this is a basic example. Of course, they use decimals and fractions, and it's hidden and kind of in disguise what the common difference is. Here, the difference turned out to be 2, but in other words, sometimes once in a blue moon you can kind of see it because the numbers are not that hard. If you know that the first term is 4 and the 9th term is 20, you could like experiment and figure out that D equals 2, you know. But if you can't see it, that's okay. You know, for the most part, I wouldn't even try to look. I would just use the formulas because it makes everything so easy. You can find D just using the nth term for this kind of a question. Then after you find D and you know that D is 2, then one more time we return to this formula and we put D in as 2 and we put N in as 75. And for a sub 1, we were told up front that the first term is 4. That's why there's a 4 here. And you do your math and you get 152. And that's the answer to that question. All right. So this is just like a puzzle. It's like a big jigsaw puzzle with all of the pieces are there, except there's one piece missing. And you're trying to figure out what that one piece is supposed to look like by trying to use all of the other things. And every little statement they give you in the word problem is a clue. Like they tell you that the first term is 4, the 9th term is 20. Like you have to use all these different formulas to try to get your answer. One thing that I've noticed when I'm doing questions like this in math is whenever I'm asked a question, I immediately look right at the different formulas that are in the textbook to see, because they basically spell out just what you're supposed to do for just about all these situations if you really understand the idea what the formula is. All right. Now, this is about sums of arithmetic sequences. Now, I want you to remember what the word sum means. Sum means add them up. So as you can imagine, sums of arithmetic sequences, they can get very large very quickly. Like you can see the answer to this last one here is in the thousands, and it's also awkward. It's got a fractional piece to it. Sums of arithmetic sequences really do mean just that. If you're talking about the sum of the first 10 terms, there's a story about what those first 10 terms are, but you don't need to know what all of them actually are. There's a way to just use a formula and get the answer of the first 10 terms summed up. And that's what we're talking about here. So in example 8, we're going to be using this formula a lot, which is the formula for the sum of the first n terms of an arithmetic sequence. S sub n is the sum itself. N is the number of terms you're adding up. A sub 1 is the first term, and A sub n is the last term in the story. All right, so in A, it says find the sum of the first 10 terms of an arithmetic sequence with the first term of 2, and the common difference is 4. And you want the first 10 terms. Okay, so n is going to be that 10. The first term is going to be A sub 1. And then the common difference is going to be D is 4. So I hope it makes sense how you can apply now this formula on the bottom here to this math right here. As you can see, everything is just plugged in just the way we just connected, and we get 200 as our solution. This question, example 8a, is the most straightforward question where you just use the formula the way it looks and you get the answer quick and easy. Try to model your homework by looking at these questions back and forth to know what to do in each scenario. For part B, we're saying, okay, the first 91 terms of the arithmetic sequence. Oh, find the sum of the first 91 terms of the arithmetic sequence, and then we have a sequence here. Now, they're telling you it's arithmetic. The reason they're telling you it's arithmetic is so that you can trust that if you subtract any two terms, you'll get D. And here that's a little bit ugly because, as you can see, it's fractions. So let's try to subtract the two easiest ones we can. I'm going to pick the two that have the same denominator right here. What's 11 minus 7? It's 4. So 4 over 12 is actually the same as 1 over 3. In other words, I guess the common difference is 1/3. So if the common difference is 1/3, by the way, I know the first term, it's 1/4, isn't it? And I know what n is. I'm trying to figure out the 91st term. So here's n. Here's the first term, A sub 1. And here is your D. So as you can see, we got to put it all together in that formula. And this is psychology. A lot of students look at this and they go, 1/3 and 1/4 and 7/12, and it's fractions and 91. Oh, I just don't like this question, and all of that exhaustion kind of comes up. But the truth is, it really is a simple substitute it all in and you'll get your answer. There it is. And as you can see, it's ugly. It's got a quarter in it. It's got a third in it. It's got 91 in it. But when you do all of your math, you're going to get 121 over 4. And is that the final answer? Actually, no, it's not, because what that is that's just the 91st term. You need the 91st term if you're going to find the sum of the first 91 terms. So the first thing we did was not find the sum of the first 91 terms, but find the 91 term. We had to figure out what it would be. That's what this formula is that we used. So now that we've used that formula, now we can apply the sum formula, which is going to be the same as the model we saw earlier, where we plug it into this part. S sub 1 equals all of this, where 91 is the n, it's over 2, and it's times the first term, 1/4, plus the last term, which in this case we've talked about is 121 over 4. You do your math, and you get your sum. This is the sum here. All right. Now, I know this is challenging, and I hope that you'll send me some messages in WebAssign when you need help with it. Remember that on Monday, I will be here in a Zoom to help you. And if you need help, I need you to come and tell me so I can explain it again for you and help you get through the homework. So maybe I'll see you Monday, but if you feel like you got a good grasp on it, you could do it without me. You don't have to come on Monday. Again, it's a voluntary meeting on Monday. All right. So let's talk now about what we can expect in the future here. That's all I have for you. That's the last math I'm going to throw at you, unless you ask for homework questions. But a little housekeeping here. Our exam number 3 will be available on Wednesday, June 29th. It will be open at 4:30 when our class is supposed to start, and it will close at 9. As soon as you open it, you have 2 hours to complete it. Unless you open it past 7 o'clock, it will close on you at 9 o'clock. You will have 2 hours to complete the exam only. You will have questions that are in different orders and that have different numbers from student to student. Also, you can only enter one-on-one answer and only, and you will not be told then and there whether you're right or not. You have to wait because grades will be revealed once all the exams are completed. It's recommended that you complete exam number 3 review beforehand, which is available right now on WebAssign. There is no credit attached to it, but exam number 3 is very, very closely connected to the exam number 3 review. On Monday, you'll see our new conclusion module will be open, and in there you'll see information about Monday's meeting and also about our final project. Okay, so thank you so much for your attention with this lesson. I'm going to stop the recording, and then as soon as I stop the recording, I'll open up the floor to any questions or concerns that anyone has. Thanks again for paying attention, and I hope you have a beautiful summer.